So here we have the function log of x with respect to the base x. So we need to differentiate it with the respect to x. That means we need to find the ddx of log of x. First, what we are going to do is we are going to convert log of x to the base x to the natural log. So we have log of x to the base of x. Now, in order to convert it, what we're going to do, we're going to use the definition that given log of a to the base b, this can be written as the natural log of a divided by the natural log of b. So we have log x to the base of x. This will be equals to the natural log of x divided by the natural log of x. So that means x log of x to the base of x is simply going to be equals to 1. So we say that this value is equals to 1. Now when we determine the derivative of log of x with respect to x, log of x with respect to x, this is equivalent to saying that we have to calculate the derivative of 1 with respect to x. Now 1 being a constant, the derivative is going to be equals to 0. So this is the answer. Let's do another one. So here we have the function given by e to the power 3 times logarithm of x. Usually in calculus, the logarithm of x, here the base is not mentioned. When the base is not mentioned, we assume that the base is the exponent e, or this is simply the logarithmic function unless specified. Now what we can do, we can use the property of logarithm that a log of b is simply equals to log of ab raised to the power of a. This is a property. So using this, we have log of x cubed. Now we have another property when we have e, the natural log of x, or simply ln of x, or we can rewrite it as e, the natural log of x, is equals to x. So that means our function is equivalent to x cubed. So when we differentiate with respect to x, the function e raised to the power of 3 logarithm of x, this is equivalent to the derivative of x cubed. Now we use the standard result of ddx of x raised to the power of n, which is equivalent to n times x raised to the power of n minus 1. So we'll get 3 times x raised to the power of 3 minus 1. So this will be equals to 3x squared. So this is the derivative of our given function when not the derivative with respect to x. Let us do another problem. So here we have another function 2 raised to the power of log of x with base 2. Or the property of logarithm also states that if we have a constant a raised to the power of the log of x to the base a, then this is simply equals to x. So this is a property. So using this property, so our a here is equivalent to 2. So that means this entire function can be reduced to x. So now we have to determine the derivative of 2 raised to the power of log x base 2. So this will be simply equals to finding the derivative of x. So derivative of x is going to be equals to 1. All you can do is we have the exponent of x is 1, so we can use the formula. So we 1 times x raised to the power of 1 minus 1. So we have 1 times x raised to the power of 0. So any number raised to the power of 0 is always equals to 1. So that means we are getting the value of 1. Let us do another problem. Now here we have the function 5 times 2 raised to the power of 3 log of x with the base 2. Now here, let us simplify this given function. Here we cannot multiply 5 with 2 because 5 and 5 is separate number. So this is multiplied to 2 raised to the power of 3 log 2 of x. Now what we can do is we can rewrite it as 5 times 2. So we are going to apply the property that a log of ab is simply equals to log of b raised to the power of a. So we have 2 raised to the power of log of x cubed with base of 2. Now since our value 2 and the base of the logarithm is also 2, so we can rewrite it as 5 times x cubed. So we have used the property that 2 raised to the power of log of a with base 2 is simply equals to a. So now when we find the derivative of our original function, which is 5 times 2 raised to the power of 3 log of x with the base of 2, so this is equivalent to finding the derivative of 5 of x cubed. Now 5 being a constant, what we can do, we can pull it out of the derivative, so this will becomes 5 times the derivative of x cubed. Now the derivative of x cubed is simply going to be equals to 3x raised to the power of 3 minus 1, so that gives us 5 times 3 is 15. We have 15 times x squared. So this is going to be the derivative of the given function, and that's it with respect to x. Let us move on to the next question. So here we have the function 7 times the exponential function. So we need to determine the derivative of 7 times e raised to the power of x. Now 7 being a constant, we can pull it out of the derivative, so we only need to determine the derivative of the exponential function. Now we know that the derivative of the exponential function is the function itself, so the final answer will be 7 times e raised to the power of x. Let's move on to the next question. So here we have the function 9 times 3 raised to the power of x. So we need to determine the derivative of the given function. We have 9 times 3 raised to the power of x. Well, immediately what we can do is pull out the constant 9 from the function, so we'll be left with the derivative of 3 raised to the power of x. Now we know that the derivative of the exponent 3 raised to the power of x, let me write the general forms, a raised to the power of x is simply equals to a raised to the power of x times the natural log of a. So let us apply this. So we have a, which is equals to 3 here, so this will be 3 raised to the power of x times the natural log of 3. So final form will be 3 raised to the power of x times 9 log of 3. So this is the derivative.